All right, ladies and gentlemen, last video that we saw for understanding object-oriented programming was the first video, and it discussed what objects are. If you didn't see that video, you're definitely going to need to see it, so take a look at the description below. There's a link. Follow that and watch that one first. At this point, watching this video, you should be able to describe what objects are, or what that means when we discuss Java or we discuss an object-oriented programming language. You should be able to discuss what state means, as well as variables, instant variables, or fields. And you should be able to discuss briefly what methods or behaviors are. You should be able to also take a look at an object and discuss 3 states and 3 behaviors of that so that you could make a general blueprint. So this video will be covering classes. By the end of this video, you should be able to understand what classes do, what they're for, and understand some basic Java syntax rules when it comes to creating classes. Syntax rules or conventions are basically the rules that you should follow, or in some cases absolutely have to follow in order to program in that particular language. So we'll be discussing the Java syntax rules. All right, so question might be, what is a class? Well, essentially, a class is your factory. It makes all the objects of a specific type. So when we create a class, it's basically a blueprint, right? And it'll help us make these objects. And all these objects share the same fields and behaviors, even though the objects themselves might be very different from each other. One example that is in the Java trails is bicycles. And if you think about it, bicycle class is a pretty general set of rules. I mean, all bicycles have tires, they all have a seat, they all have a gear or a set of gears, so forth and so on. But if you think about it, bikes are very different from each other. I mean, yeah, sure, there's a particular bike that was probably made a couple million times, but there's such a variety of bikes. So a class is that basic blueprint to help you create either that same object multiple times over and over and over again, or if the class is written in such a way, it allows you to create different types of a same object. So different types of bikes, even though they're all a bicycle object, right? So some conventions that we have to adhere to in Java. Well, Java classes are all defined in their header. So a header is usually your first line of code, though not always. We'll worry about the details in the future. But all headers for a class have an access modifier. In this case, we've used public. A class keyword. There's some keywords that are reserved in Java you can't use for any other purposes. One of them is the literal word class, and we see that down there below. And then the name of the class. Now this could be anything that we want. In this case, I'm calling it animal. All right, so my header, as we see it now, access modifier public, class keyword class, and then the name of the class, which I've decided to name it animal. One thing we should note, that class names always should start with a capital letter. Now I'm going to be honest with you, if you program it and you compile it, you won't get an error if your class name isn't capitalized. But Java convention, especially when you're working in a professional context, we expect that your classes start with a capital letter. As a matter of fact, to add a little bit of complexity, though not too much, you'll see that below, any class names that have more than one word in them should follow camel case when we're programming in Java. So here's an example. We still use the access modifier, the class keyword, but this one's called spirit animal. Because it's a class name, it starts with the capital S, spirit, and then the second word you'll know doesn't have any underscore, doesn't have a space, nothing like that. It's camel cased. That means it's got that other capital letter there. So spirit animal. So those are some of your basic conventions. Some more. Every class has a beginning and an ending brace. So if we look, now it's a little bit more complex than what you just saw. Still have the access modifier, public. I still have the class keyword class, and I have the name of my class, animal. And then you'll see I have this brace right here, which is an opening brace or a left brace. And then I have this right brace or this closing brace. So all the fields, all the methods, every bit of our program will be in between those two braces. And there'll be other braces in the future too, but we know that that is the beginning and the ending of the whole program, or the class in this particular case, and everything for this class must fit within those braces. So some basic rules for you. So again, why do we create classes? Classes allow us to very easily create objects, and depending on how varied the fields and states and behaviors are, we can create lots of different types of objects. I'll have a short example after this so that you can also see it in a real life context. All right, so we have so far discussed objects in object-oriented programming and classes. So let's take a look. I have in front of you 3 objects of the same class, and I have a separate object of a different class. Now, these 3 objects are of the socket class. You don't need to know too much about sockets, just know that they're all from the same class. They're all the same object type, sockets. Now, they have certain states, like the size of this socket happens to be 5/8, and another state is, well, is it clean or is it dirty? And another state could be what type of socket, at least the entrance here, and this is hexagonal. So this socket is also a 5/8, so it has the same state as that last one does. It also shares another state, hexagonal, though you can see one of the states are different, and that's the bottom here, and there's a particular reason for that, but we won't worry too much about what the reasoning is behind that. And then I have a third object of the same class, the socket class. You'll see that it too shares the same size, 5/8, but it is different in depth. It's only about 1 inch, and it has a 12-point insert as opposed to a hexagonal. Now, these objects, which are all instances of the socket class, share a lot of similarities as states, but they also are able to be different, and we could see that in lots of different types of sockets and stuff. There's different sizes, different states, but when it comes down to it, even though these instances are different, they are all of the same class, which is socket. Now, some behaviors that we could have with a socket, well, we'll just talk about one, is connected to ratchet. All right, so one of the behaviors or the functions we can do is we can connect it to a ratchet. So now that one is. So this is a good example of how objects from different classes could also work together to create something different or work together. We'll get more into that in the future, but that should give you a good idea of how classes create objects such as sockets that can be different, though they share the same types of states and behaviors.